Hello good day viewers. In this tutorial, I'm going to show you 3 different ways to find the maximum value of y in any form of quadratic equation. And you should know that a quadratic equation only has a maximum if and only if the leading coefficient is negative. You can see this is the leading term and the coefficient is negative 2, meaning it is going to be what? An up and down parabola. If we have y and x-axis like this, this point, exactly where the curve takes a turn, the corresponding value of y at that point is said to be the maximum value of y in this equation. So at this point, we have value of y right here, and we can have a corresponding value of x right here. So I'm going to start with the first method by transforming the equation into a vertex form. And a vertex form will be what? The value of x at that point, which we normally represent with h, right? And the corresponding value of y at that point, which we normally represent with k. So if we are able to transform this into a vertex form, the value of k at that point is said to be the maximum value of y in that equation. So let's get started. If you have y equal to, which is the general form of any form of quadratic equation, ax squared plus bx plus c. If you have something like this, a vertex form is given as y equal to a multiplied by x minus h all squared then plus k. This is the vertex form of this quadratic equation. But what is the vertex? The vertex, that is the turning point. The values of x and y at that point will be what? H, comma, k. How can you obtain h? By taking x minus h and set it to be equal to 0, solve for x, you're going to get h. And this is going to be k, which is the value of y at that point. Therefore, the maximum value of y will be what? K. So let us transform this equation into this form that we pick the value of k at that point, and that's said to be our maximum value of y. So this is what we have. If you want to transform it into a vertex form, first of all, you should consider the first 2 times. Just keep the constant now. And you have to factor out the coefficient of the x squared. So we have y equal to negative 2 outside. Inside, already negative 2 is outside, remaining x squared from the first term. And if you take negative 6, you divide by negative 2, you're going to obtain positive 3x. Give a space for a number, then bring minus 4 back. And what will be this number? We want to transform this binomial into a perfect square quadratic trinomial. And the number to add here will be square of half of the coefficient of x, which is 3. So 3 divided by 2 all squared will be the magic number you're going to add here. So this is going to give us 9 divided by 4, right? So this is 9 divided by 4. But remember that 9 divided by 4 wasn't there before. It was added for a purpose. Therefore, we are going to neutralize it. How? Take this, multiply by this. Negative 2 multiplied by 9 divided by 4. You know 2 can go into 4 2 times, so this will give us negative 9 divided by 2. This negative 9 divided by 2 is exactly what we have added naturally. So therefore, since we have added negative number, we are going to add positive number to neutralize it. So we're going to add positive 9 divided by 2 instead of this negative 9 divided by 2. All right. So now this is a perfect square quadratic trinomial, and it can be factorized as, this is negative 2 multiplied by, you take x without power, then you take half of the coefficient of x, half, 3 divided by 2, that is half. Then you square all. If you expand this, you have to get this back. Then this will be, what will be the simplified form of this? You take this, you multiply by this, it is going to give us negative 8 plus 9 is positive 1 divided by 2. So we have positive 1 divided by 2. Can you see that? It is now written in a vertex form. And I told you this is the value of k, right? and it is said to be the maximum value of y at that point. So therefore, the maximum of y is equal to 1 divided by 2, as simple as that. Now let me show you the second method. And you should take note of the value 1 divided by 2. We are going to get the same thing. The second method is by applying calculus. Remember, our curve looks somehow like this. This point, that is that critical point, exactly where the parabola or the curve is at rest, trying to take a turn, because it was increasing like this. It reached a maximum point where it stops at rest, then it started decreasing. That is how the curve looks like. So at this point, the first derivative of this function will be equal to 0 because it is at rest. So we're going to differentiate this function dy on dx, which is equal to take this power, multiply by the coefficient, it becomes negative 4. X, the power will reduce by 1, it becomes 1, right? 2 minus 1 is 1, so you don't have to write it. Then minus. Naturally, you know this has a power of 1. It will multiply negative 6. You have negative 6. It will subtract 1. 1 minus 1 is 0. X to the 0 is 1. 1 times this is still this. And the derivative of constant is 0. So we stop here. And I told you the first derivative, this is our first derivative. At this point, it is equal to what? 0. At dy on dx equal to 0, what do we have? We have that negative 4x minus 6 equal to 0. Take this to the other side. You have negative 4x equal to positive 6 as it crosses over. Divide both sides by negative 4. X equal to 6 divided by 4 negative. To the lowest term, we have 3 divided by 2, right? So x equal to negative 3 divided by 2. But what is this value? This value is exactly the value of x at that point. Remember, we are looking for the value of y, which is somewhere here, right? So you can take this value of x, substitute it into your main equation to get the corresponding value of y, and that's what we are going to do. Remember that x was negative 3 divided by 2, right? That is what I have simplified. Therefore, y will be equal to negative 2. X, replace it with this value, negative 3 divided by 2. It has a square, you square that, minus 6x, which is negative 3 divided by 2, then minus the constant. Simplify and get the value of y. This to the power of 2 will give us 9 divided by 4. So this is negative 2 multiplied by 9 divided by 4. Minus, right? Is plus, so this will become plus. And you know that 2 can go into 6 3 times. 3 times 3 is 9. Then we have minus 4. 2 can go into 4 2 times, so we have negative 9 divided by 2 because we have reduced 4 with 2. And this minus this is going to give us positive 5, right? 2 times 5 is 10. 10 minus 9 is 1 divided by this 2. You can see that this is 1 divided by 2, and this is the value of y. And I told you this is going to be the maximum value of y. Therefore, this is what? Maximum value of y is 1 divided by 2 in this equation. And we're going to take the last one. And the last one, we have a general formula to find this y directly. Whether it is minimum or maximum, always use this formula. Y equal to what? 4ac minus b squared divided by 4a. As simple as that. But what is a, what is c, what is b? A is the leading coefficient, negative 2. B is the coefficient of x, negative 6. And c is the constant, negative 4. Substitute them here. Therefore, y will be equal to 4 times a times c. 4 times a times c minus b squared, that is negative 6 all squared, divide by 4 multiplied by a, and a is negative 2, negative 2. Negative, negative is positive, right? 4 times 4, 16. 16 times 2 is 32. So we have this equal to 32 minus negative 6 to the power of 2 is what? 36. 36 divided by 4 times negative 2 is negative 8. So we have negative 8 here. 32 minus 36 will give us what? Negative 4. So this is going to give us negative 4 divided by negative 8. The negative will cancel the negative, right? 4 can go into a 2 times. So this to the lowest term is 1 divided by 2. Can you see that? We have 1 divided by 2. And we conclude that the maximum value of y is 1 divided by 2. As simple as that. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.